Hi there, and welcome to Hyundai Power Products. My name is Adrian, and today we're going to look at this Hyundai HYM510SPE lawnmower, and specifically the electrical system. So there's nothing more frustrating than having an electric start lawnmower, and when you push the start button, nothing happens or you just get a click. So the aim of this video is to help you sort out exactly what's wrong. So the electrical system on this mower is really quite basic. It consists of two switches, a solenoid and the starter motor and the battery. So let's look at the battery first of all. So the most common cause by a long way of a non-starting lawnmower is a flat battery. So we're going to take the cover off the top of the battery and just test to see what voltage it's at. So to take the cover off, we need to remove these two bolts. So I've got a 10mm socket here, but you could use a 10mm spanner just the same. I'll just loosen these bolts off. Okay. Unscrew them completely. Lift them out of the lawnmower. And I can carefully remove this lid. Okay. So we've got the two terminals of the battery, the positive and negative terminals. Each have two wires attached to them. The positive has a red wire which goes to the little charger point here, and a red wire which supplies the lawnmower with 12 volts positive. Much the same with the negative, a small wire that goes to the charger and a large wire that goes to the body of the engine on the lawnmower. Okay, so let's get the multimeter and just check what voltage the battery is at. Okay, so a quick test with the multimeter. Got it set on DC voltage. I'll put the black on the black and the red on the red. 12.98 volts. Absolutely wonderful. Plenty of power in this battery. If your reading is less than 12 volts, like 11.8, 11.5, you know, that sort of area, 11.9, you should get a response when you push the button. You should hear it turn. But anything less than sort of 11.8, then you will need to charge your battery. So the next possibility is that we've charged the battery with a battery charger in through the little port on the side for 5 hours. We've got to use the mower again and still no life in the battery. It's still at the same voltage it was when it started. Now that could be one of two things. It could be a faulty charger or it could be a faulty battery. Okay. So a quick way to test to see if it's the charger or the battery is to see if the charger's working. So to do this, we'll plug the charger in, we'll plug it into the little socket and see if we see a voltage change on the battery from where it is now. So I plugged in my battery charger and the output from the charger is plugged into the battery box. So we would expect to see a rise in the voltage regardless of what the battery voltage was to start. We would expect to see, when we measure the battery, a rise in the voltage. So we were at 12.9 volts initially. So I'll just test the battery again, and as you can see, 14.27. So that's a rise in the voltage. If I just unplug the charger, test again, 13.28. Now that will drop back down to around the 12.9 after a few moments. So that tells us that the battery charger is working. It's outputting a voltage above that of the battery. Okay. If the battery voltage was, say, 10 volts, I'd expect to see sort of 12.3, 12.4 voltage when I measured across the two terminals. So you will see a rise from its base point to know that the charger is working. So in this case, we know that the battery charger and all these wires are connected correctly and that the battery charger is working. So we've charged the battery for 5 hours with a known good battery charger, and the battery voltage still hasn't come up to the 12 volts plus that we're looking for. If that's the case, then the battery will need replacing. If you didn't see a rise in the voltage when you plugged the charger in, then the charger will need replacing. So we've gone through the charger and the battery side of things. So while we're in here, it's just worth taking a little look for any damage, any broken wires. We can see these two wires, the black and the red, they're coming through. Let me just untwist those. Okay, so you can see the black goes to the black terminal, everything's tight here, and the red goes onto the red terminal, and everything's tight there with no loose or broken wires. So we've ruled broken wires out of the system or out of the sequence of events. Okay, so we can now replace the battery cover, knowing that we need a new battery or a new charger. So we've gone through these tests on the battery and the charger, and everything is fine. The battery is fully charged, the charger's working. Still no activity when we push the start button on the mower. So we'll move on to the next stage. So this lawnmower is what we call negative earth, the same as most motor cars nowadays. So what that means is that anything metal, especially the engine block, is connected directly to the negative on the battery. So the black wire on the battery comes down, and in the place on the back here, it joins onto the metalwork of the engine. So we need to check that connection. So yeah, we're testing for a bad earth. So I'll just set my meter up on continuity, so when I've got a circuit you get the beep. Okay, so if I put my black terminal on the negative terminal of the battery and touch on the engine, I've got continuity, so I know that the negative is connected to the engine. Now let's check for a bad earth. So we may have an earth but with a resistance in it. So the way to check for that is to do voltage again. So I'll set my multimeter back on DC voltage, set my range on double figures, so it's anywhere between 10 and 99 volts. So I think you can see the meter there. So what I'm going to do is go from the positive terminal to the negative on the battery as a base figure. As you can see, 13 volts, 13.01. And I'm going to put the negative now on the engine, 13.01. So I've got exactly the same voltage measuring between the engine or to the negative. So I know I've got a really good connection between the negative terminal on the battery and the engine. So we can rule out a problem with the negative side. So if during that test you found that there was a difference in the voltage or a lower voltage between the engine block and the positive terminal and the negative terminal and positive terminal, then we need to dig a little deeper to see where that resistance is coming from or where that bad connection is coming from. So the first thing we would do is just make sure that the connections on the battery are clean and tight. They may need cleaning up with a little wire brush if they're dirty or corroded, so we would do that first. We would retest it to make sure that we've solved the problem, and if not, we need to dig a little deeper to the grounding point on the engine. So I'm going to do a little bit of stripping down of the lawnmower and bring you back to show you where that is. So I'm just going to remove the top plastic cover, the recoil start, and the blue cover underneath. So this black cover, the recoil, and this blue cover. So for the black cover there's just 2 screws at the back here, one either side. We'll remove those. There is another video that shows this in detail, a video on changing a recoil start. Okay, so we'll lift that out of the way. Again now, 10mm socket, undo the 3 nuts that hold the recoil on. So if you want to see this in more detail, have a look at the fitting a new recoil start video. It'll show you how I'm doing this. Okay, 3 nuts removed. Remove the pull start. Remove the fuel filter. And I can remove that blue plastic cover. Okay, I'm actually going to remove the fuel tank and bring it out of the way now. So it's a 10mm bolt both sides, so I'm going to do those. So with the top pieces removed and the fuel tank removed, we can now see pretty much all of the electrical system, and it's going to make it a lot easier for me to show you, and if you do remove them, a lot easier for you to work on as well. So you'll see this short lead here, which comes directly from the battery with the red and the black lead onto the starter solenoid, which is this unit here. Now the black wire from the battery comes down and joins onto this bolt here. So if we were getting that drop in voltage between the positive and the engine in comparison to positive and negative on the battery, it would be this terminal here that we would need to clean if it were dirty or corroded at all. So we know that on this particular mower we haven't got a drop in voltage, so we know that that connection is good. So once you've cleaned up this connection, we're all reconnected, we can again do the same test as we did earlier between the positive terminal on the battery and the engine block, and it should be exactly the same reading in voltage as it is between the positive and negative on the battery. So the positive connection from the battery comes directly to this terminal on the starter solenoid. So we need to do the reverse check to the one we just did and check between the negative on the battery and this point here, and we should be back to that 13.01 voltage as we were before. So we'll just check that. So the solenoid is basically an electromagnetic switch. It uses a negative and a positive to energize a coil inside itself. When that coil is energized, it becomes a magnet and it throws out a push button, shall we call it, which makes a contact between these two large terminals on the solenoid. So what it does is joins this battery out through this terminal and off through this thicker cable to the starter motor. So that's where the starter motor gets its positive from, and it gets its negative from the body or frame of the engine. So you'll notice that there are two wires coming onto this terminal. One is coming from the battery onto this terminal, and the other one is coming from this terminal up to the main push button switch. We have the main push button switch here. So we need to check the operation of this switch, and we can do that by testing back down on the engine end. So you'll see the red wire goes up to the switch and comes back as this black wire here. So this is permanently 12 volts positive, and only when the switch is pushed is this black wire 12 volts positive as well. So this black wire goes to a secondary switch which is operated by the OPC. We shall show you that. So the OPC handle is here. It serves two functions. It makes the switch that allows the start circuit to work, and it also breaks the circuit which kills the spark plug, but we're not going to look at that. So you'll see as I pull the OPC lever, the lever moves here against the spring. It releases the brake on the flywheel, but it also releases this little switch here, and you can hear it clicking. So yeah, you can see the little switch. If I pull the OPC lever, you can see it releases this switch. So you'll see the two wires going to the switch. That's this one here and this one here. So you've got a black one and a clear one. The black one, if I just pull the sleeve back, is the 12 volt positive supply to this switch, which basically comes from the start button. So if I push the start button, I should measure 12 volts between this terminal and the body of the engine, or the 12 volt negative. So I got my 12 volt negative lead on the engine. My meter set on DC volts again. If I just probe that terminal with my red lead, I get nothing. If I push the start button, again I've got my 13 volts. So that tells me the start button is working. If you get nothing when you push the start button on this terminal, that pretty much tells you that the problem lies with the start button. So if we diagnose that the start button is faulty, then we would replace the start button and carry on. So we need to know that this switch, when the OPC lever is pulled, that this switch is making a circuit. So I can do that with just a beep test again. 2 seconds. So I got my multimeter somewhere handy. So with the lever not pulled, I should get nothing there. As you can see, if there was a circuit, I get a beep, and I have nothing. So let's try it when I pull the OPC lever. Let's see if I can just get these fastened in here. Appreciate I can't do this on voltage single-handed because I've got to pull the OPC lever and push the start button, and then I could test for 12 volts on this terminal. So all I can do is just check that I'm getting continuity. So a probe on each. When I pull the OPC, the switch releases and I get a circuit. So I know this switch is working. If that didn't happen and when you pull the switch you've got no continuity, it could be one of two things. It could be the adjustment of the OPC, or it could be a faulty switch. So you can see the little lever on the switch. When I pull the OPC, this pin will move forward, releasing this lever, and you'll hear it click. Yeah, so when I release the OPC, click. That's broken the circuit. When I pull the OPC, another click, and that makes the circuit. So that tells me that the OPC is operating correctly. And if I'm not getting continuity when I pull the OPC across the two terminals, that pretty much tells me that this switch is faulty. And again, it will need to be replaced. So the wire coming back from that switch comes into this line, into the coil of the solenoid. And you'll see just tucked in underneath is the black line, or the negative supply to the solenoid, which is again fastened on this bolt on the bracket. It may be worth just cleaning up the contact between the negative lead and this bolt before we go any further. But having said that, if it's all nice and clean, you probably did it when you cleaned the other terminal. We now know that when we push the start button and have pulled the OPC, that this coil should be energized. So we need to test to see if the solenoid is working when we do those two things. So a simple test for the solenoid. If I pull this handle and push the start button, we will hear it clicking. And that tinny clicking sound is the little rod going back and forwards in the solenoid, which is supposed to make the connection between those two large terminals. So we need to check that when this solenoid fires, as we heard it fire, is making the connection between the two large terminals. If at this point the solenoid does not fire and you don't hear that clicking noise, then we now know that it's a faulty solenoid. Wire from the solenoid comes here to supply 12 volts positive to the starter motor here. The starter motor gets its negative directly from the engine. So we'll do a little visual first of all, make sure it's not loose and everything's connected correctly, and the starter motor is still solidly mounted onto the lawnmower, so we know it's not a problem there. So what I'm looking for is a 12 volts reading between this terminal here and the body of the starter motor when I push the start button and pull the OPC. I've just put my positive probe on there, and my negative probe is into a hole in the engine to give me the negative. So when I now pull the OPC lever and push the start button, I should be seeing the 13 volts there. And I will also hear the solenoid click, but I would expect a slight drop in voltage because the solenoid itself does consume a little bit of power. So, we hear the solenoid click, 12.6 off. 12 point, I can't quite read it, I'm the wrong way around, but as you can see, I've got the voltage there. This pretty much tells me that the full electrical system, all the switches, the battery, the solenoid, everything is okay. I'm now going to reconnect this lead back onto the starter motor. Yeah, it's just a little rubber boot. Connect that lead back on. Make sure it's all nice and clean, which it is. Because again, if this terminal were dirty, it would cause the same problems. Put the rubber boot back on. Right. If I didn't get the 12 volt reading out of the end of this lead, when I pushed the starter button and pulled on the OPC, but the solenoid was clicking, it pretty much again says that the solenoid is faulty, or the switch within the solenoid is faulty, and we would need to replace the solenoid. Okay, so now I'm connected back to the battery. I know the starter motor has 12 volt negative because it's connected to the engine, and I know that it's going to get its 12 volt positive when I go through that procedure. of pushing the start button and pulling on the OPC handle. So I'm just going to step away from this area now. I wouldn't recommend you do this with no covers on because this will spin, but I have removed the spark plug cap so the engine won't start. So if I now pull on the OPC and push the start button, I'd expect the starter motor to engage and the engine to spin. And it does. So that tells me that everything is now working correctly if I've gone through all these procedures. If the starter motor didn't engage and spin the engine over, now we can point directly at the starter motor itself and we would need to replace the starter motor. One final thing, I've got the spark plug cap removed, just to check that the engine isn't seized and it isn't a problem within the engine that's stopping the whole thing turning. If I pull on the OPC, I should be able to freely revolve the engine, which I can, up until the point where it hits compression on its stroke. So that just shows that the engine isn't seized, because that's obviously would stop it rotating when you push the start button. So I think if you follow this through step by step as I have, you'll get to the root of what the problem was as to why the engine wouldn't spin over and start the engine when you use the electric start. So one separate part of the electrical system is this unit here with the lead going to the spark plug. And this is what we call a coil pack. Basically, as the crankshaft rotates, there's a magnet on the side of the flywheel. Now let me show you that magnet. I'll just bring it round into sight. Where is it? There. Oh, hang on, I'll have to go right round against the compression of the engine. Okay. So there's a magnet here embedded into the flywheel. As that magnet passes by these two halves of this iron bridge on the spark pack, it produces a current in this area, and through induction, this coil pack in the center generates a spark of high tension current to the spark plug cap, to the spark plug, and the spark plug will spark. If you're not getting any spark, it could be one of two things. It could be a faulty spark plug or a spark plug that needs cleaning. There's a separate video on that. Or it could be, again, a problem with this OPC. So you'll see this little wire here. When the OPC lever is pulled, it breaks the circuit or the negative ground circuit to this wire. When you release the OPC lever, it grounds out this spark pack, stopping it sparking. So there is a switch which switches this current or this ground on and off. So on the end of this wire, which has got this white sleeving on it, goes to a little brass spring-loaded pin under this metal bracket. And this metal bracket, being part of the engine and joined to the engine, is ground or 12-volt neutral. So it will ground out the spark pack when the little brass pin is touching this plate. So if when you pull on the OPC, I'll do that now, you can see the little plunger. You pull the OPC and this lever will swing around far enough to break the contact between the metal part of the lever and this little plunger. So breaking the continuity of that circuit. When we release the OPC, this lever comes across, makes contact with the brass pin, and also sends that 12-volt negative onto the coil pack, which kills the spark. So if your OPC lever isn't adjusted correctly, you'll find that the engine won't start. On the same note, if when you release the OPC, the engine doesn't stop, it could be one of two things. So it could be a bad connection on this terminal here, so that the grounding isn't getting onto the end of the terminal, or it could be a problem with the switch. So if we remove this wire, we would expect the engine not to stop. So what we would do is just pull this wire off. It is on there very well. I'll just pull it off. So to test the switch, I've just pulled this little wire off. So again, I'll get my multimeter, and I'm looking for continuity between anything metal on the engine and this when the OPC lever isn't pulled. So exactly the same test. I'll put one end of the meter into that switch and touch the other end onto anything metal, and that's making a circuit. So what I'll do is I'll pull the OPC lever and the circuit is broken. That's correct. Okay, so we know that's operating correctly. If that circuit isn't broken when we release the OPC, we know it's a fault of this switch here and it will need replacing. And on exactly the same note, if the circuit isn't made when we release the OPC, the switch is faulty and we would need to replace the switch. If you're still getting no spark, and we've been through these tests, again, we can pull this wire off, so we're ruling out any other problems. And if we're not getting a spark when this wire is removed, we would suspect it to be a faulty spark pack, and the spark pack would need replacing. Okay, so we've been through the complete electrical system, whether that be the starting circuit or the spark system. Everything's operating correctly and our mower is now ready to go again. So I'm going to put it all back together and we are done. Well, I do hope you found this demonstration useful. For more information on this or any of our other products, visit www.hyundaipowerproducts.co.uk. I've been Adrian and thank you for watching.